Willkommen zu dieser 3D-Druck-Podcast-Folge. Das ist eine Podcast-Folge auf Englisch. So, welcome to the 3D Printing Podcast, the technology podcast covering all aspects of additive manufacturing. Whether you are new in 3D printing, an experienced user, or a 3D printing service provider, manufacturer, or accessories supplier. So it's not just about having a 3D printer, it's about using it in a smart and cost-effective way in your business. I'm Johannes Lutz and I'm excited about today's episode because it's titled Better SLS and Multijet Printing, Nesting and Build Preparation with AMIS Pro. So if you are a SLS or Multijet Fusion 3D printing service provider or user, and nesting and build preparation are part of your daily task, so listen closely. I'm here today with Kris Binon from AMIS. And Kris, nice to see you. Please introduce yourself briefly and what does AMIS do?
Right. Well, first of all, Johannes, thanks for having us here at this podcast. I think it's a wonderful opportunity to indeed deep dive a bit into the complexity and importance also of build preparation in general, nesting specifically. I'm Kris Binon, as you said, managing director with AMIS, and AMIS is an internal startup to the Hybrid Software Group. Hybrid Software Group is a larger software group, mainly active and it's around 300 people, active in software for 2D printing. And basically that explains already how AMIS got started in the first place. I myself come from a 3D printing background. I started talking to the TCO of Hybrid Software Group, somebody I've known for 3 decades already. We started basically seeing opportunities to improve things. And because, of course, there is other build preparation software. We're not the only ones in the world. And then specifically when it's about jetting technology, including multi-jet fusion and later on also SLS, there's quite a connection with 2D printing because basically it's sequential 2D printing in one layer on top of the other. And there was a lot of expertise internally with Hybrid Software Group. I came with my background from 3D printing. We saw the opportunities to basically come with a better, easier software tool, and then specifically aimed at those technologies. So we're not catering for all 3D printing technologies, but just for those 3. And yeah, that's how we set off about 3 years ago. Meanwhile, we got a good selling product, and we still have lots of ideas on how to improve that. So it's still a small group, and we keep it intentionally small because then we can move fast, we can move forward, really focused on the questions, on the demands from our users. So that's AMIS, and that's where we are at this moment.
Very, very nice. So let's start at the front. So how actually needs nesting and or who actually needs nesting and build preparation in 3D printing, and why is it so important?
Yeah, very good question. And there's a lot to answer to that one, or potentially to answer to that one. I would say everybody who's in 3D printing will need some kind of nesting, will need some kind of build preparation, whether you're in FDM printing, or whether you're in laser powder bed fusion for metals, you will need build preparation. And in some cases, that's like mission critical. If you don't do a good job, you will just have a failed build for sure. And in other cases, it doesn't matter too much. It's like, okay, it can be something you would want to do because it improves maybe your cost and your quality a bit. So, and typically with these technologies that we're talking about today, MGF, SLS, and also jetting a bit in general, it can be really mission critical. It's really about getting your products right, getting out the quality that your customer expects you to print. And then, but it's much more than that. It's also, and that's maybe not mission critical, but it's still very important because it allows you to save costs, to have better builds, better quality out, which means less parts that break, but just also higher density, meaning you get more profit out of each batch, out of each print. So in the SLS and MGF range, it really goes from maybe not so important for some parts up to very important because you save a lot of money and quality for majority of parts, up to mission critical, because in some cases you will know that your part will just not come out in the right way if you didn't do a good build preparation. So it's a bit of all that, let's say.
Yeah. There's a lot of situations there. So what are so typical situations where 3D printing service providers and in-house users working with SLS and MJF struggle with nesting and build preparation?
I think in a sense it's quite logical that it's always a bit of a struggle, and it will some things will remain a struggle. Let's be honest about that, because quite often parts themselves just have like a conflict of interest. Meaning, for some parts you would want to say, like, and we'll come to the example later, a threaded round part, you will want to put that straight up in order to make sure that the roundness is maintained, that your threading will actually work in there. And that may conflict with the requirement for another surface, which you want maybe to be askew in order to have a certain quality of that flat surface. So there might be a conflict of interest there. And that's, I think that's also, by the way, the creativity that a person doing build preparation needs to have. They need to be able to find that, or to solve that conflict of interest, let's say. But nevertheless, in order to get there, in order to get your part positioned in the right way, in the right place inside the batch, that can be frustrating indeed, because it's just taking a lot of time to put your parts in there, to rotate your parts in the right direction. And quite often, by the way, we're talking about hundreds of parts, of course, inside one batch. So imagine doing them one by one. And that indeed is frustrating. That's a struggle to work with that. So we really try to provide tools to make that go faster and easier, and just that you go through this whole preparation phase quite a bit quicker, let's say. And then you come to the nesting. So okay, you prepared all these parts. You now want to put them in the perfect way inside your batch. You click nest and you wait 10, 15, 20 minutes or something, sometimes even longer, and you get a result, and maybe it's not a result that you actually were expecting, or rather and that's again because it's such a complex matter. You have a result and you see, like, yes, I'm 99% okay with that, but that part I shouldn't have done that. I should have put it like that. I should have moved it a bit more there. Or the result that came out gave me indeed, like, for example, a large flat surface next to the wall of the build box, something you would want to avoid. You see, so then you're like, I missed it. And then you have to restart and reposition that part maybe, or change a bit to it. And then you have to re-nest again. And again, you're waiting for 20 minutes. So that's quite frustrating. I think we tried to solve that mainly because of the speed of the nester, which is quite a bit faster than the other solutions that exist. And that means that this iteration, which anyway will bring you to a better result, becomes an option. You can really iterate through to get to the best result that you think, like, yes, this is the thing that I want to have printed, and this is the thing where I trust as an expert in what I do, that it will come out just fine. So it's really this focus on taking away these frustrations that we have. On the other hand, yes, it's a creative job almost. So it's understandable that well, maybe the fun is also part in this struggle.
Yeah.
But that's what I would first think about this indeed.
Yeah, a lot of service providers say that's a never-ending story with nesting. So the last 30 minutes before starting the machine, a new part is coming in, and they have to do this again and again and again. And that's That's frustrating. I know from this target group. Yes. So what do you really gain from doing nesting and build preparation? Probably.
Apart from saving on your frustration, you mean, right?
Yeah. Yeah.
Yeah, indeed. Well, first of all, and I think it's yes, you win time when you go through faster and when you nest faster. Of course, you win some time, and that's very nice because it's basically means, of course, that there is less costs to the batch itself. But I think that's only part of the story. The batch itself is going to be less costly, so to say, because there was less time spent in it. But you free yourself. Because quite a lot of service bureaus, quite a lot of in-house printing, people who do in-house printing, they anyway have limited resources, and they're not like with doing 20 people doing the build preparation. So you want to save the time also in order to be able to focus on other things in your production and maybe scaling up other things, automating other things, perhaps by using AMIS Runtime or automating engine. So winning time is really vital in many organizations. And it does also mean, like, yes, you save cost with the winning time, and that it's itself is a very important thing to focus on. But you don't only reduce your cost because you save time, you also reduce your cost because you will have less parts that are basically having failed builds or parts that are not in the right quality. And also there, you can put more parts in a job. So if you can put even 1% more density, now 1% more density often makes a difference between 10% density and 11% density. So that's a 10% gain there that you get inside your build. That reduces costs significantly, of course. So that's also a major driver for doing better build prep in general. And the third one is indeed, but I kind of mentioned it already, quality. Quality has an impact on your cost, but it also means taking away a lot of frustration, because we do see it quite often. I mean, yes, once in a while a part comes out and it's not the quality you want it to be, so you want a reprint. Now, a reprint in itself might not be the biggest cost, but you can't keep that promise to your customer. It needs to be in the next batch, so it's only ready by tomorrow, so delivery is a day late, and that's it goes beyond just the cost of the reprint. I think that important. So for me, those are three very important drivers actually to concentrate on good build preparation. It's the cost, it's the quality, and it's the time that you spend on it.
At question 2, you talked a lot of part orientation. So what is most important when it comes to part orientation? So how would you maybe orientate a bearing block, a film hinge, a threaded bushing, a flange plate, and with a sealing surface? So what can you say about that?
Wow, difficult one. Because again, there's a lot to say about it. First of all, there is something like generic nesting rules, and for example, we're working closely with HP, who has also given us their nesting rules, which is basically a set of relatively simple, you would say, rules that can be translated into if then else. This is so really in a structure that you need to integrate that into software, meaning like if you have a thin wall and it's larger than 10 square or 100 square centimeters or something, then do this or don't do that, things like that. And both in SLS and in MGF you have those basic rules. Of course, and I mentioned it before, sometimes they are conflicting within one piece. So it's not always that straightforward. And also, like in the examples here that you mentioned, there are a few special cases. You mentioned the threaded bushing.
Mhm.
That one, um, you will put it upright. So you will
Mhm.
put it up straight so that basically the roundness is maintained. And of course, that means that you need to be able to translate that into your build prep software. Also, you need to put a part and you need to lock it, either lock it in position or indicate that that part should not be rotated during the nesting. So restrict the rotation axis on that one. That might conflict with the next example you were talking about, the bearing block.
Mhm.
But let's assume it doesn't have threaded bushings left and right. Um, Okay, if you have need a precision fit somewhere, a flat plane that needs to
Mhm.
remain as flat as possible, that's actually the plane you want in the XY direction. Yeah, so flat down, let's say. Well, most of the time, luckily, of course, the threaded bushings will be in the other direction, so you will have a perfect combination there, but that's not necessarily
Mhm.
always the case. And also there, you're going to restrict the rotation. You will probably, for such bearing blocks, they can be pretty heavy. So you will probably want to increase the gap distances on the side so that it remains more that it keeps more distance from the parts next to it,
Mhm.
in order to basically maintain the quality of that part.
Mhm.
Oh, you also mentioned hinges, right?
Yeah,
The
yeah, yeah.
living
Maybe a
hinges.
film hinge or something like that.
Yes. Well, good that you, because the living hinge is something you would put in a different direction from because a normal hinge, if it needs to rotate, you want to keep that roundness, and you're probably
Mhm.
going to look at an upside down positioning of the axis,
Mhm.
like a bit like the threaded bushings. Whereas a living hinge, and making use of basically the flexibility of that the powder, that the polymer is offering you, that you probably want to put straight down, and so
Mhm.
in this direction, so you wouldn't have a notch, or potentially having a notch in there, so that will then be the better choice. So you're going to place it down, lock it in position, and
Mhm.
or lock the rotations there, so that it comes out in that same way.
Yeah.
So another one, another rule, maybe, let's say, but quite important, is
The
that
flange, you need a flange, or what
sorry.
you mean? Do you mean the flange that as the next part, or
Oh yeah, the flange plate. Yeah,
yeah?
well, it's a bit. I think I mentioned before, the planar
Mhm.
stuff, the one that needs to actually do the sealing, that needs to be
Mhm.
really flat. That's the one you're gonna put on top
Yeah.
there. Um, and you might want to use this in increase, because also there might be quite a bulky part, so keep some more distance from the side from the other parts. Um, you also, yeah, should be a bit conservative on the density in that case, so that you don't basically, because parts also have an influence on each other. It's not like you have one part inside the build box. If other parts are too close, they get an
Mhm.
influence on that part. So yeah, or they have an influence. So you have to keep some more distance in some cases of heavy parts, let's say.
Yeah. So that's a lot of information. So how can we summarize this completely in yeah, mini decision checklist for nesting, so
Yeah,
to make it a little bit easier? What do you think are the important things in
yeah.
this checklist?
Yeah, luckily you warned me on that question, because of
Mhm.
course this again, there is really too much to say on that, and we could, for example, give these HPMGF nesting rules as an example. That's
Mhm.
what was a 5 or 7 page document. Um, but just to stay brief here,
Mhm.
I would say, first of all, is the function. What will the
Mhm.
part need to do?
Mhm.
And then, of course, the shape might be less important, but the function is important. Like the flat parts that need to be flat. Really, okay, we're gonna put them up. The threaded balls, we want them to be round. We may have to make
Mhm.
sure that the roundness is not affected. So we're gonna put them up upside down. So function is the first thing you look at. Now, of course, we also know that in some cases, the function of the part or the function is maybe not so important, but it's more about how it looks. And then also you have a couple of rules saying like okay, there is always, there usually is a side of the part that you want the quality to be higher, that it looks very neat on that side. So that's then the one you're going to put up or down depending on the case, and flat again in order to prevent the stepping or the fact that you still can see the different layers inside. So that's something to avoid there as well. Another one that you have to keep in mind is the type of material you're printing with. PA12, PA11, they're a bit different. You're gonna want to be a bit more conservative when you print with the PA11, keeping some more distance, a bit less density in general inside. And then with the TPU can be also tricky. There you definitely if you have bulkier parts with a thick cross section, you'll have to be careful, and there's a limit even to that. You could say you might then want to put lattices inside to avoid too much buildup of heat, and or just shelling them. That can also be a solution. So keep in mind which material you're printing with. Good. Yeah, I did mention briefly before, but it's a very important one. The center of your build box is where you will want to put the more fragile parts. Fragile or impactful, or how can I put it generally? Basically, the bigger ones. The bigger parts, you're going to want them in the middle, whether they are a thin, large surface. And there's a lot of drone printing nowadays, typically very large surfaces. You will want to put those in the middle, but just as well the bulky part, the big part, you will want to put that in the middle. And actually, that doesn't have so much to do with the printing process itself, but even more with the cooling process afterwards, because the outsides will cool more quickly, and so all temperature change will have an impact on the stresses inside the part. So that might play an influence when you cool down the parts, and that's why you want to put them in the middle. Next one in these general rules is of course your density. I mean, density is super important. I already mentioned the influence of parts next to each other, but in general, the heat buildup, definitely so in SLS, of course, where you got the lasers really working in that. The heat input really will have a big influence on your quality. So keep that in mind. So you will need to check your density. So you need a tool a graph basically showing your density and the possibility to adjust your density. And so we got, I think, quite a powerful tool to do that. We have the max layer density function, which really allows you to limit the density for each layer to a certain density, so that you never go too high in layer densities. That's an important one as well. Now, I could go much more in detail there, because apart from the layer density, you also want to check if there is not like a lot of density in one corner of your build and then nothing in the other on the other side. That's still a bad situation, because your layer density might be okay, but your spreading is bad. But also there's quite a few tricks and ways of achieving that in our software AMIS Pro. So yeah, don't worry about it. Or rather, you have to worry about it, but there are ways to work around it and to solve that, actually.
Yeah. So to summarize a little bit, function, material, put the parts into the center, the cooling, density. What was the sixth point? We lost them both, but it's a lot of information.
The most important ones. Another one that that could be still important is the rotations and maintaining rotations, because quite often what you will want to do is that if you once found out that, okay, this rotation is perfect for this part, quite often in many cases we see that there are reprints. In some cases it's even that the company's printing 80% of what they do is just reprinting of old orders. So you will want to maintain that rotation. That's not a job for AMIS in a sense. It's not. We're not the ERP or the MES system of your organization, but we do realize that this connection is super important. You need to be able to communicate upstream and downstream in your workflow in order to, for example, remember the rotation of certain parts and then give that back to the system so that it's actually stored in there. And with that, we already are very far with Phasio. Company providing MES ERP specifically for additive manufacturing, but we're also talking to the other providers in that sense to see how we can better connect and better integrate the two solutions. But to come back to the point, keep your if you're happy with your rotation, keep it and lock it so that it's basically always the same. Let's say, yeah.
Yeah, I think it's a learning process, step by step, and how to look what is looking nice after printing and whatnot, and change your recipe from part to part. Yeah. So, who has already seen major benefits from using AMIS Pro? So, can you share a practical example?
Yeah. Well, luckily we already have a few examples, but I can't share them all. 2-3 names I could mention. It's 3ID in Belgium. It's a pioneer in NGF technology. By now they have 5600 Pro series. So
It's good.
A nice amount of printers already. There's rapid prototyping in the Netherlands, and they're totally on the SLS side, and they have quite a few SLS printers there, mainly EOS. And a third one I think now about is 3D People in the UK. Also, quite a big, one of the biggest in the UK providers, print service providers. And they, well, we're still in close communication with them. They've really seen the benefits. I mean, really, I think the number one is that they just went down 60-80% in time that they need to do their build preparation. And
okay, that's a lot.
In one case I know for sure, like 3ID here in Belgium, they're gaining 2 hours a day. They used to have 2 hours and a half per day on build preparation. Now they do it in half an hour. And these 2 hours, I mean, yes, you can imagine the cost, of course, but indeed, as I mentioned before, it allows them to do more, to do other things, to look at other things. So that's really a huge difference there, and that's mainly driven by the fact that our nesting is super fast. That allows you to change a lot. So there was a lot of build preparation time gains. I think in another case, but I can't name the customer, but they're doing only insoles, and we work together with them because, of course, if you're only doing insoles, it means that if you can put in 108 insoles inside your batch instead of 104 with the same quality outcome, that's just 4% or nearly 4% more profit. And that's super important. And you can only do that if you, and I didn't mention the word yet, but it's super important, if you have the right nesting strategy. Because your choices in nesting will not only be decided by the parts they will be decided by the parts, but it's not like, okay, I will always use the same way of nesting because I have this machine and this material. No, if your parts are different, you might want to try another strategy, and looking into that really can make a change in your business planning. So that was a very good example, I think, whereby we didn't only save on time, but also really increased the bottom line of the company. And
Yeah.
that's the case. That's always the case, but sometimes it's more obvious than in other cases.
Yeah, that's clever nesting. I tried it myself. Your software, and I was clicking on nesting, and I was waiting 4 seconds,
Yeah.
and it is finished. For me, it's more like, okay, is everything wrong here or something like that? No, he's doing the whole job in this fast way.
Yeah.
Crazy. Very crazy. This is
I'm glad to hear that.
That's great. So I can say 60 to 80% less build preparation time.
Yeah.
I understand this. This is a lot. There's a lot of time for sitting in front of this computer and click a lot of your desktop to look at the right orientation. So what does the typical workflow in AMIS Pro look like when you want to nest something?
There is no typical workflow.
Okay.
Well, there is a bit. There is a bit of a workflow, of course. I mean, we typically make it a distinction between part preparation and build preparation. And you start off with a part preparation, so preparing all your parts so they will lead to a good nesting, to a good build preparation. But that's just two concepts which will help you going through, I think, quite quickly. I said there is no typical workflow, but I'm mainly saying that because we see that in reality, all these people doing the build preparation, for me, they are like a chef in a kitchen, and they all have their own recipes. And not only that, the one is a chef of a Italian restaurant, and the other one is a chef of a Chinese restaurant. So they're doing different things with it. And in the case of additive manufacturing, you've got companies doing only insoles, doing only dental, or doing daily mixes. And that's a huge difference, which requires a different strategy, maybe a different workflow. And so the job of AMIS is just to be the kitchen, to offer the cutlery and the tools, and it's all close by and easy to use. And the chef gets to know. In the beginning, you have to get to know your kitchen, of course. But that's our job in this. We have to be the kitchen, and the kitchen allowing you to be either the Italian chef or the Chinese chef or whatever you have to be for your job. And since you mentioned it before about this speed, yes, you can have the case whereby you have your batch ready, and then 10 minutes before you want to start printing, somebody calls with a super urgent order, and you still want to put it in, and you have to restart. And that's the case with some of our users, and they need they need other tools, and they need the speed, and etc. And then we have other users that say, like, first, for example, in the first communication we have, they say, like, for us, speed is not important. We never print the same day. We always run our nestings overnight, and in the morning we get a result, and that we print. And they don't change that recipe. So we also have to cater for that possibility. And it's just how your company is working, or how your company wants to do that. So a typical workflow, no, but you will in your company probably build your own workflows, build your own strategies, still plural. And what we also notice that because they are chef, how to put it, they look at the ingredients and they know how to deal with it. Meaning, quite a lot of these guys, definitely, if they have been working with AMIS for AMIS Pro for a couple of weeks, they see the parts they have to nest, and they almost don't have to iterate anymore, because they already know, like, okay, with this kind of parts at this division, I will do my trick 1, 2, and 3, and do my strategy 4, and click, and there I go, and it's done. So that's how you can also evolve in this typical workflow idea, let's say.
Okay. So how can a SLS or multi-jet fusion user can take a closer look to the software and the speed and into the kitchen, in his new kitchen?
New kitchen. Right, perfect. Very easy, because if you just go to our website amispro.be, you'll see a button there saying like download here, and then you can just have your own download there. It's installation is just a couple of minutes. You will get automatically a 7-day license. By the way, quite often for companies seriously considering it, they might need more than 1 week, and we will be glad to extend the license. So don't worry about that one. And anyway, we strongly suggest to just have a brief demo together, to really go through, preferably even through your batches or your specific cases, because that really helps. I mean, if I would have given my standard demo to the guy with the insoles, we wouldn't have gotten that far. So yeah, but we really think it's important, because otherwise you will not know all the tools in the kitchen, or we have that also. I mean, then they've been using AMIS Pro for 3 months, and then they call me and ask like, can we just sit together and have a look at this or that? I'm having this trouble. And then I just say like, yeah, but there's this shortcut that you just do click, and oh, I didn't know that. Nobody reads the manual, right? Who nobody wants to read the manual. That's normal. So you can just ask, and that's also why we think this common session just to go through it together is very important. So yeah, glad to work on that for sure.
Yeah, I think it's the best way to put your own parts into it and ask some questions. What is the best way? What is easier? How is the easiest way to work in this kitchen with all these tools around and make your own experience. So before the last question, so how will the software evolve? What is next? You say one word, AMIS Runtime. What is this? What is in the future?
Yeah, sure. Well, maybe I do want to tell more about AMIS Runtime, but more in general, we're really working. Okay, it's very much demand driven for sure, but there we really make a distinction between, I would say, feature sets, generic value adding feature sets, so bigger than just one feature, that we know like it's going to bring a lot of value to our users. For example, a lot of Boolean operations that we were currently working on to make holes inside the parts, to put on label and text and things like that. So that's a feature set. The other one is, and I mentioned it before, the HP nesting rules, which we will put in automated part rotation, orientation, automated nesting possibilities, which are, if you have an HP machine, based on the HP nesting rules. If they're not, we are working on, of course, similar systems for the SLS rules. So that's also one of these sets. The connectivity is also, improving the connectivity is also there, a set upstream and downstream of features that we're working on. The other way, so that's one way of developing things. We're working on that. The other way is really demand driven, even more closely, saying like, okay, we got sometimes new users that say like, I really want to run AMIS Pro. I'm happy with it, but let's make a deal that you can have this feature, which is for me, for my company, really vital, that we have it in by September 1st. And then we say like, okay, we agree on that one. And so we work a lot with these deadlines, which are then part of the deal. And it's okay because it brings value for everybody, but for some it's more important than for others. So that we put a deadline on it makes kind of sense, let's say. And then you mentioned it correctly. AMIS Runtime is basically the automated AMIS Pro. So it's headless. You don't have the interface, so to say, but it's fully scriptable. And we actually, before it was a product, we already use it internally for our own testing purposes, for testing the software. So it's basically allowing you to script anything. It's an API, on which you can give all the same commands and even more than you would be able to do in AMIS Pro. And there, I think, yeah, people who are interested will immediately see the possibilities, because it allows you, for example, to say, like, first to do an analysis of the parts that you have to nest. And based on that, create your own, again, strategies to say, like, okay, I got this type of parts inside. I got 6 batches to fill with it. Okay, now let's start dividing the parts over the different batches so that it makes sense, that it's logical, not just one after the other. Keeping in mind priorities of certain parts, so that they're printed earlier, etc. And then you can start looping, and you can do that day and night and continuously. So new order comes in, no problem. It's just added, and everything is re-nested just instantly according to this set of rules that you decided. So you can make easily scripts that can recognize, okay, this is a flat part. If it's a flat part, let's do this with it. This is a bulky part, let's do that with it. So you see that you can go at once much broader in possibilities, and it runs automatically. Does that mean the chef wouldn't have any work anymore? Absolutely not. I can't believe that. The chef will still be needed to like in a real restaurant or kitchen, to check on the result, maybe add a few spices on top, change a few things before it's ready to actually go out to go to the printer. So he wouldn't lose his job; he will just gain time by doing that. So AMIS Runtime is really, and it's already been installed in UK in one big facility. And it's looking really promising there. So so that's what's going on within AMIS at the moment.
That's very, very nice and great to take a view. Yeah, take the right view into the future. So from your point of the view, what are the most important takeaways from this episode? How would you summarize them well? What are the key points?
First of all, the people doing the build preparation, they're chefs, and they can be considered as such. And I think if you're the boss of the restaurant, you need to give these guys the tools to, well, come with better products, because they are basically making money for your company. They're really having a big influence on how your company's quality will be perceived, how the cost will be of each batch, each part. So yeah, it's more than technical. It's I mean, a good chef is not just technically good. He really adds value. He can have an impact on speed, quality, etc., etc. So I think that's one very important thing to remember. Secondly is indeed about the strategies, and also about, well, maybe once in a while changing your strategy. I do see some cases whereby people have been using a certain nesting strategy for all the years that they've been working with additive manufacturing. And then you come in and you say, like, you start working on batches together, like, oh yeah, and why do you do this and why do you that? And just by asking questions, you sometimes come to ideas that say, like, okay, well, maybe we should change that strategy. And really, strategy can have a big impact again on the final results. I would say, yeah. And thirdly, of course, here's the promotion part. Feel free to contact us, and we'll be glad to look into it together. Of course, that's my big takeaway. Let's say.
Yeah. So we have all the information in the show notes for doing that very fast.
Thanks.
when you're hearing that, to all the listeners. So to the end of the podcast, I have for every interview 2 personal questions. So please finish this sentence. 3D printing is for me.
Yes, it's about creating things. But it's more than that. It's the combination of creation and creativity. I think that's and a perfect mix in that. And maybe that's why the comparison with a chef and with a kitchen is not too weird, because it goes beyond just creating parts. It's really the creativity of changing how parts are made, changing how we look at final assemblies or even the functionality or the potential functionality of parts, and that's that combination of engineering and creativity, I think is what it is for me.
Okay, great. And what's the coolest printed part you ever hold in your hands, or in one hand maybe?
Yeah, in one hand.
One
So
hand
it
or two
should be
hands?
too big. So not a printed building then. Okay.
Yeah.
Yeah. It's this. I don't have to think about it. I thought it was really amazing. It was this eyeball printed by Stratasys, multicolor, which was so extremely realistic. I don't know if you've ever seen it, but it's really wow. It's like it could be a dinosaur's eyeball or something. It's super realistic, and it's cool because it's so nice. It's so extremely well done. But it's also cool because it's definitely in the jetting technology, which we're also very much active in with MGF. You see the possibilities if we go one step further, like adding more materials or more binders inside, or more colors is one thing, but imagine that it's not just about colors, but about different material properties and what you could put inside. Imagine that every artery in that eyeball would be actually electrically connecting things or something like that. So we can still, it's just the beginning, and that eyeball gives a very good idea, like, of what it could still become in the future. And I think that's maybe also why.
Yeah, that's a great part. I think I saw this on Formnext,
Quite possible.
or maybe on a picture, but see it on a picture is completely different than see it in real life.
Yeah.
Yeah. So we are at the end of the podcast episode. Kris, thank you very much for all this information. That's a lot, but I think it's very good for all the people that are using SLS, multi-chat fusion, doing the build prep more cleverly right now.
Yeah.
So we have all the information into the show notes, your phone number, email address, the link to the website, LinkedIn, and all the other stuff you have. And thank you very much for that. So
well, thank you, Johannes. It was a nice opportunity. Thank you.
see you.
See you around.